Alright, in this video we will be talking about Amazon AutoScaling, CloudWatch, and simple notification services. So let's start with Amazon AutoScaling. Why would you use something like AutoScaling? Let's look at the traffic of a popular website. This is just a graph plotting website traffic versus time. You can see that the traffic peaks during the fourth quarter holiday season in the financial year. So this is probably some kind of e-commerce website, and they see a 4 to 6x spike in traffic. So the reality of these websites is they have different network traffic throughout the year. With e-commerce websites, for example, they have a burst during the holiday season. Now, if you have bad performance in your website, then you're likely to lose customers. So that's a big no-no for many of these companies. So you should have the ability to dynamically vary the size of your system for various reasons. The one shown on screen is just one of them. Let's look at how hardware scaling traditionally works. In this plot of capacity over time, the blue line shows the fixed capacity increments that are made over longer periods of time, and the red line denotes the actual demand. You can see that in the early stages, you can see that the fixed capacity curve exceeds that of actual demand, so they are able to satisfy the demand using their fixed capacity. But you can see after a point, there's a point where they did not predict the actual demand well enough, and they stuck to a particular fixed capacity. When the demand exceeded the capacity, they have the potential for losing customers because the website won't be responsive. The fixed capacity will not satisfy the demand at that time. Also notice that prior to this, the area shaded in gray between the two curves is actually wasted capacity. You have provisioned resources higher than what you actually need, and this area will denote that wasted capacity. Now, with autoscaling and the ability to scale resources dynamically at a much faster rate than what you would do with traditional scaling, your curve is going to look somewhat like this. In this curve, you can see that the virtualized infrastructure can be scaled on demand with varying according to the actual demand of the website, and it can be done quite quickly compared to traditional scaling. This allows you to do two things. When your traffic spikes up, and you have an unexpected jump in demand, because of the rules that you defined for scaling the infrastructure dynamically, you should be able to keep up with your demand. But at the same time, you only provision a little more than what you need, so you minimize the potential for wasted resources. So, how do you use Amazon's auto-scaling? Let's start with something that you're familiar with, the existing architecture that we've used in previous projects with ELB. So in such an architecture, you have a user load that interacts with a forward-facing elastic load balancer. Typically, you'd have a couple of EC2 instances sitting behind that elastic load balancer. Now, all that autoscaling group does is set up a bunch of rules and monitor a bunch of metrics. So after monitoring a bunch of metrics, if there is a certain condition that gets satisfied, defined by some of these rules, such as the scale in or scale out rule, you will affect the size of the group of instances sitting behind the autoscaler. So ASGs allow you to scale Amazon's EC2 capacity automatically according to conditions that you define. So we just introduced a new concept in the previous slide, which is Amazon CloudWatch. How does Amazon CloudWatch work? Well, Amazon CloudWatch can simply monitor resource metrics for a specified alarm condition. For example, you can ask Amazon CloudWatch to monitor CPU utilization and then set an alarm if the CPU utilization increases above, say, 90%. When such a condition is met, you can perform some form of automated action. In the case of ASG, you will ask the ASG to increase in size, for example. Maybe if the CPU utilization or memory utilization falls below a certain threshold, you could ask the ASG to decrease the size of the instances. So here's a simple schematic to show you how this works. And it's also important to note that CloudWatch works with multiple resources, not just EC2, but other resources such as Amazon DynamoDB and pretty much anything else that you can provision with AWS. Let's take also a quick look at Amazon's simple notification service. This is a useful service to let you know when actions are being performed in AWS, such as scale-ins and scale-outs. Simple notification service is a fast and flexible messaging service. Publishers can push messages whenever certain events happen. For example, a publisher in an auto-scaling group is the actual scale-in and scale-out rules, or these alarms that get triggered when during a scale-in or scale-out rule. They can be publishers in AWS. Messages will have to be sent to an SNS topic, and any subscriber to an SNS topic will instantly receive a message. This can be typically done through SMS or emails. So how do you use simple notification service with autoscaling? Assume a scale out or scale in event happens. This will trigger an autoscaling rule, which will also trigger a autoscaling rule notification. This rule notification will send a message to a registered ASG notification topic. Any subscribers to this topic, for example, your email address, will instantly receive a message whenever these events happen. Now that we've talked about all of these services that Amazon provides, let's look at a case study. We'll explore Netflix. Obviously, Netflix is a very popular media streaming service in North America, and they've been using Amazon autoscaling groups for about 3 years. They take advantage of multiple ASG features. They can manage running a pool of servers, they can replace failed instances in their autoscaling group, and they can automatically grow and shrink the size of their server pool. They've done a couple of studies that show that the use of ASG greatly improves the availability of Netflix services and provides an excellent means of optimizing costs. You can read more about this in their blog, as shown on screen. Here's a very interesting graph of server workload over time and the number of servers over time, and as you can see, the number of servers that they provision closely follows the server workload. If you pay special attention to the x-axis of time, you can actually see that these server adjustments are being made in the interval of a couple of hours. The resolution of these graphs show that adjustments to their server pools are made by the hour, so they're able to respond quite quickly to server requests, and you can also see that they're able to respond to hourly changes in Netflix demand. For example, according to this, sort of the late evenings and afternoons seem to be the highest time in which their servers have the most amount of workload, which makes sense, which is their customer base, when they're back from work or they're relaxing at home in the evenings, that's when they are more likely to use the Netflix service. Accordingly, their servers can scale to match demand.